In this video, I'm going to talk about the learning target. I can run a quadratic regression to find a quadratic model for a set of data, and then I can use my model to solve a real-world problem. So number one says the table shows the fuel efficiencies of a vehicle at different speeds. So as you're driving certain speeds, your car gets a relative miles per gallon gas mileage based off the speed you're traveling. We want to get a function that models this data and then use it to approximate the optimal driving speed. Okay, so what we're going to do here is we are going to run a quadratic regression to get the information into our calculator. So the first calculator step we're going to do is we're going to go into stat and we're going to edit. Okay, that's the first step. This is just like linear regression. So when your calculator's on, you're going to click stat, you want to hit enter on edit. We want to put the x values in L1, we want to put the y values in L2. Okay, so just to show that again, what I did there is I clicked on stat, and I hit enter to go into edit. Okay, so this is the edit screen. Adjust this a little bit. There we go. Okay, so once you have your data in your calculator, now you want to run the regression. So you're going to click back on stat. We're going to go over to where it says calc. And then this time, instead of doing number 4, it's number 5. We want the quadratic regression. Okay, and that'll give us our equation. So the second step, after you have the data in your calculator, is to click back on stat, cursor over to where it says calc, and then you want the quadratic regression. Okay, so when I did that, it gave me this equation. You'll notice it puts it in standard form. Y equals ax squared plus bx plus c. And then it tells you what your a, b, and c are. So you just need to plug in those values. So I get the equation y equals negative 0.014 x squared plus 1.4x minus 7.14. Okay, that is the model that fits this data. Now I want to use this model to approximate the optimal driving speed. Now the trick here is, if you think about the graph for a second, a quadratic that's negative is a parabola that goes downwards, right? So this graph's going to look something like this. And if I want to find the optimal driving speed, that means I want to find the speed. So if x is the x-axis are my speeds, I want to find the speed that's going to maximize my miles per gallon. So my y's is miles per gallon. So what I'm really doing is I'm finding that maximum point. That's the optimal spot. That's where the speed on the x-axis meets the maximum miles per gallon. So if I want to know how to get that optimal driving speed to maximize the miles per gallon, I'm looking for the height of the vertex. Okay, I'm looking for the vertex. I want to know what that height is. That's the miles per gallon. That's optimal. And then the speed that's with that is the optimal driving speed. So to do this, I'm going to use my calculator. Okay. What I'm going to do is I'm going to type this equation that I just got. And I'm going to plug it into the calculator. So to do that, you go into y equals, and then you just type in the right hand side here. So negative 0.014. You'll find the variable next to the alpha button. So that's x squared plus 1.4x minus 7.14. Okay, so now I have the equation into my calculator and I want to make sure the plots are turned off. Now I'm going to go ahead and click zoom 6. That's going to zoom to the standard window, and then I'll adjust from there. Okay, so you'll notice I can see a little bit of my line, but it's getting cut off, so I need to widen it out, and I'm going to also make it a little bit taller. So if I click Windows, instead of going to an X max of 10, I'm going to try an X max of 50. I'm going to scale it by 5s, and I'm going to make the Y max 35, and I'm going to leave that as 1s for now. Okay, notice I made an adjustment. It's still getting cut off. I need to go a little bit wider, so I'm going to click back on Windows. I'm going to make this 100 scaled by 5s. Okay, now you'll notice I can see the full parabola in my screen. Okay, so once again, I'm trying to find the vertex because that's going to tell me where that maximum occurs, what speed that's at. So to do that, you click second trace, and it brings you to this screen. Now this screen lets you calculate a lot of different values. We want to find where that maximum is occurring, so we're going to use number 4 down that says maximum. So I'm going to click maximum, and then you'll notice it says left bound. So I want to go to the left side of the maximum, so I'm just going to click to the left of the hill, hit enter. Then it'll say right boundary, so I'm going to move to the right side of the hill, click enter, and then it'll say best guess, and then I go in the middle. Now you'll notice when I was putting the left bound and the right bound, you'll notice 2 arrows came on my screen. What that's doing is it's telling the calculator that the maximum has to be between those 2 arrows, and now we're giving it the best guess. We give the guess in the middle, and it says we have a maximum at 50, which is 27.86. So the vertex here at 50 is 27.86. So when it says what is the optimal driving speed, well, driving speeds are my x values. So in this case, it's going to be 50 miles per hour. Okay, that's the speed that you want to go if you're trying to maximize your miles per gallon. All right, let's go ahead and look at a second example here. So it says the table shows the estimated profits Y in dollars for a concert when the cost is X dollars per ticket. So once again, we want to get the data into our calculator. So we're going to start by clicking Stat Edit, and we're going to enter the X's in L1, the Y's in L2. So if I go ahead and do that, 2, 5, 8, 11, 14, and 17. And then I want 2600, I want 6500, I want 86, 89, 74, and 41. Okay, once the data is in my calculator, I want to make sure the 2 tables end at the same spot. And then I want to run the actual quadratic regression. So to do that, I can click back on Stat. I go over to where it says Calc, and now it's number 5 that says quadratic regression. So if I run that one, it tells me the equation is y equals negative 100x squared plus 2000x minus 1000. Okay, so this is the quadratic function that models this data. And then it wants me to evaluate the function to determine what cost per ticket should maximize profit. So once again, if you think about that graph, okay, we have this parabola here. We want to figure out where that maximum is, what price is going to give us that maximum value. So we're looking for this x value of the maximum, which once again is the vertex point. So to do this, we need to type this equation into our calculators. So we're going to go into y equals, we're going to clear that out. I'm going to type this guy now in. So negative 100 x squared plus 2000x minus 1000. Okay, so now the equation's in my calculator. I'm going to adjust the windows. The reason why I'm doing this is I look at my x's and it goes 2 to 17. So I'm going to make it sure it goes from negative 10 to 25. I just want to be a little bit bigger than those. And then your y's, you'll notice they're in the thousands, right? So I'm going to go up to 50,000. I'm going to scale it by 100s. I'm going to graph that. Okay. You'll notice that I'm a little too tall, right? So I can make an adjustment. I go back to my windows. So instead of 50,000, maybe I go 25,000, half as much. Okay, that gives me a little bit better picture there. I could shorten it a little bit more, but I'm okay with this. So once again, I want to find that maximum point. I want to find the top of that graph. So I click second trace, which takes me to this screen. And I'm looking for that maximum value, so that's number 4. So I'm going to click enter on that. And then you'll notice it asks you questions in this left-hand corner. It says left boundary. What that means is if I'm looking for the maximum, I need to go to the left side of it and click enter. When I do that, it puts a little arrow on your calculator. Okay, then it says right bound. So you go to the right side of the hill, you click enter, it puts a little arrow there. What that's doing again is it's telling the calculator that the maximum we're looking for is between those 2 arrows on our graph. It then says best guess, so you go in between the 2 and you give it the best guess. And then it says you have a maximum when x is 10, if you round it, so when x is 10 and it's 9,000. So the vertex here is at 10, 9,000. And so it says evaluate to determine what cost per ticket would maximize profit. Well, we're going to get the maximum profit when the cost is $10. Okay, so $10 is the price that we should make each ticket cost if we want to maximize profit. And if we wanted to know what the maximum profit is, it's going to be $9,000. So max profit would be the $9,000 part of it. Okay, so max profit's 9,000. The optimal cost that we need to get that max profit is to put them at $10.